When I select OPM in the Views panel, I get the triple data viewed with Dov-Dory's object process methodology. At least it is my best guess about it. As you can see, it looks like the directed graph I get when performing the natural language query with a few differences. The car underscore part of predicate is replaced with a shaded triangle representing an aggregation dash participation structural link. All RDF type relations are replaced by a triangle with a shaded circle in the center representing a classification dash instantiation structural relation. The wheel underscore of underscore car subject node graphic is replaced by a box with a delta 1 and delta 2, meaning that it is an object that changes state. This state changes because e.org / contribute underscore 1 is considered a process in OPM. The REA outflow predicate is replaced by two arrows showing that contribute changes the state from delta 1 to delta 2. The prov started at time and prov ended at time predicates are replaced by instrument links. It is unclear whether any of the RDFS is defined by predicates should be classification dash instantiation links, since I assume that they can only occur between classes. The W3C ontology for WhereNet, where the word sense URIs come from. There is a schema that contains the main classes senseset, wordsense, and word. The wordsense URIs appear to be instances of this wordsense class. They do not appear to be classes themselves. We can select the wheel underscore of underscore car class instance and see the corresponding class wheel underscore of underscore car and the car underscore part of ontology on the right pane. We can select the Fresnel button to remove the license. Anything with a RDFS is defined by property, and anything with a RDF type property. Selecting the GSS button gives us styling, and selecting RNW base gives us distributed version control for triples. RNW base, or raw base, by Emil van der Sande et al. Describes triple store structure as a connected directed acyclic graph. A graph describing the versions of the triples is provided below the namespaces. I'm not sure if this graph will be created on the fly for this particular selection of triples, or if it will refer to the evolution of a particular linked data, platform, container, resource, collection, etc. Here is the same graph as the previous slide, but with two contributors. On the raw base graph, I see I have two branches merging at this point. On the object process diagram, I see the wheel underscore of underscore car object with three deltas, delta 1 prime, delta 1, and delta 2. The rest of the diagram is identical with the exception of being replicated for two contributors. If I click the RAA button in the value network /star panel, I see another process for e.org /paid appear on the object process diagram. I am not sure whether putting a RAA transfer predicate link between e.org /paid and e.org /contribute underscore 1 is correct for OPM. I mean to indicate that the e.org /paid process has something to do with the e.org /contribute underscore 1 process. In other words, the graph should say http example.org /outsiders /fof.rdf #me is paying http bshambha.org /fof.rdf #me for a contribution to wheel underscore of underscore car. In a broader sense, what is happening might be more accurately described by example with Bob Hogan's value streams. For example, an outside agent may ask to buy a car, and I may be signed up to build a wheel of any car that is sold. Thus, the outside agent buying a car would cause me to contribute a wheel. In return for the car, the outside agent would provide some compensation, of which some would be payment for contributing a wheel, which is what the diagram shows. References include value streams, github.com/b Hogan /value network, all lowercase, no spaces, /wiki /value-streams with V and the S capitalized. Second reference, Miel van der Sande et al. RNW base, git for triples. A third reference, RDF/AL representation in WordNet, W3C working draft, 19th of June 2006, at www.w3.org /T R /WordNet-RDF lowercase. And fourth, Dovdori, The Visual Semantic Web, unifying human and machine semantic web representations with object-process methodology, Technion, Israel, MIT, USA. And fifth, Dovdori, object-process methodology and its application to the visual semantic web, pre-conference tutorial part 1, ER-2003, Chicago, October 12, 2003.